All right, boys and girls, this is the last video example for day one. Example 4, finding an angle of depression, and we're going to be doing the checkpoint on page 327. So again, I already took the liberty to draw the picture for you. That's my plane. Okay. So you can either follow along on in the book or just while I read to you. Okay. So here we go. At a point, nope, wrong one, sorry. From the time a small airplane is 100 feet high and 1600 ground feet from the landing runway, the plane descends in a straight line to the runway. Determine the angle of descent in degrees of the plane. Okay. All right, so this is what I have so far. When we talk about descent, descent is like going down, okay? Versus elevation is going up. So this is the drawing that I have, but believe it or not, I'm actually gonna kind of I don't know how to say this, maybe like do like a mirror image of this. So what I'm gonna do is I'm gonna draw another triangle over here. Okay, since we want an angle of descent, we're looking for this angle right here. Okay, how much does this plane have to descend and then go straight to the runway? Okay, so I'm just gonna call this theta because now we're looking for an angle. Now 1600 feet can also be written above, and then of course we're working with the right triangle, and 100 feet can also be written this way. Okay, so I can basically just label my sides this way. And then, so technically, if this is my angle of reference, I have the opposite side and I have the adjacent side. So I'm going to work with tangent. Okay, so if I had to set this up, I would say tangent of theta equals opposite, which is 100 feet, over adjacent, which is 1600. Okay, if I wanted to simplify this, I could just, cross out the zeros and I would have 1 over 16. So basically, whenever you solve for an angle, now we're going to do the inverse. So theta equals tangent inverse of 1 over 16. Okay. Now, if you don't want to simplify it, that's fine. I just decided I wanted to simplify it. But now you're going to be using, now you're going to be using the inverse because we're solving for an angle. Okay. And so again, you're just going to be using your calculator. So second and then tangent, and then I could just leave it as a fraction, 1 over 16. And that should give me approximately 3, and it is an angle. So you could say 3.58 degrees, or usually angles, we actually like them as whole numbers. So ready? Tangent, because it's an angle, you could say approximately 3.58 degrees. So it has to have the degree symbol, or, and I don't know how the book is going to have it at the back, but usually we like to have our angles as whole numbers. So I'm just going to write theta is approximately 4 degrees. Okay. And that's my answer. Again, if they don't say round to the nearest 10th, 100th with angles, I'm just going to stick to the nearest whole number, but I'll go ahead and include both. Okay. So that way you could see. All right. And that's pretty much it, guys. But I'm going to go ahead and do one more example for angles of depression. Okay, so here we go. Next one. If one of you students is a really good artist and you're mocking my airplane, please forgive me. I don't know, it almost looks like a bat or something. I don't know, it looks weird, but whatever. It'll do the trick. Okay, so again, here's my other example, and I already took the liberty of drawing it for you. Let me read you the word problem. Okay, it says, from the time a small airplane is 250 feet high and 5,200 ground feet from its landing runway, the plane descends in a straight line to the runway. Determine the plane's angle of descent. So I apologize, they didn't give you a whole lot of variation, but pretty much the same thing. Okay, again, angle of descent is how much we're going down. So do you see that a plane cannot go down here because the plane's not going to go straight down like that? a plane's going to go down at an angle, but it's going to eventually start straightening out here. So this is why we kind of have to mirror this triangle. Okay. So I'm just going to mirror it. And then my angle of elevation would be here. Okay. So again, I can label this 5,200 feet. We know this is a right triangle, and then this would be 240 feet. Okay. So based on that, I'm going to be working with the top triangle. This is my angle of reference. So I'm working with opposite side over adjacent. Okay. And all we have to do is find the angle. So this would be tangent. I'm going to go ahead and call this theta again, okay? Tangent of theta. You can even call it x, whatever you want. I'm going to stick to theta. Tangent of theta is opposite, so 240 over 5,200 over adjacent, okay? And again, if I'm solving for the angle, I want to use theta equals tangent inverse. I can simplify this fraction, but I'm not going to this time. I'm just going to put 240 over 5,200, okay? And then now you're just going to let your calculator do the work. Sorry, there's a bit of a glare. I have my light on. Okay, so here we go. Second and tangent, and then it's 240 divided by 5,200. And so this would be approximately 2.64. But again, I want a whole number just because it's an angle. So I'm just going to say 3 degrees. So theta is approximately 3 degrees. I know you're probably wondering, why are they so small? Well, obviously, a plane is not going to go like weird, right? It goes down and then eventually just will, they go further down here, but eventually they straighten out. But yeah, just a little bit. Okay. All right, boys and girls, you have enough to do today's homework. But before you start on the homework, let me give you an example. And as always, if you have trouble, just come back in the chat. Okay. All right, boys and girls, good luck.